This is a carbon nanotube. It is lighter than aluminum but stronger than steel, with a high electro and thermal conductivity. Its most fascinating attribute is its high strength-to-weight ratio, which is around 11 to 63 GPAs. The reason why they're so strong is due to the nano size, which prevents defects and allows it to approach carbon's theoretical strength. But perhaps the biggest reason is due to its molecular structure. Let's take a look. Here's a Bohr representation of carbon. It only has 4 valence electrons with 4 empty gaps in the second ring. Because of this, carbon is inclined to bond to become stable. However, electrons don't travel in rings but in orbitals. Carbon has the s and the px and py orbitals due to Hund's rule. However, for carbon to bond with itself, it must hybridize, in this case the sp2 hybridization. This is where one of the 2 s electrons is promoted to the pz orbital and then set aside. In doing so, we create 3 degenerate orbitals, the sp2 orbitals. These orbitals naturally arrange together and form covalent bonds with the other carbon atoms. The strongest bonds, sigma bonds, form at the point of overlap, and pi bonds exist between the lateral p orbitals preventing rotation. The sp2 bonds are also super strong due to the high s character of 33%. This bonding naturally forms hexagonal shapes, nature's strongest and most efficient shape. This makes sheets of these hexagons graphene super strong. CNTs are just graphene or single sheets of graphite rolled into a tube. How does this happen? Well, there's a method called chemical vapor deposition. A tube is heated to a high temperature and chemical gas containing carbon is pumped in. The gas saturates a catalyst, typically iron, with the carbon, and the byproducts are pumped out. Once the catalyst is supersaturated, the carbon nanotubes begin to grow out of it. Due to its unique properties, carbon nanotubes pave the way for new technological advancements, including the most efficient computer, synthetic muscles and prosthetics, even space elevators. Carbon nanotubes pave the pathway of a tubular future, and we're about to get roped in.